Argand plane and polar representation. This comes under complex number. Let us consider an x-axis, y-axis. O is a 0, 0 origin. Let us consider 1, 2, 3. Minus 1, minus 2, minus 3 on the x-axis. Plus 1, plus 2, plus 3 on the y-axis. Minus 1, minus 2, minus 3, minus 4 on the y-axis. So this is x-axis and this is y-axis. Here, let us consider a point at 2, 4. So this is x, 2 and 4. So this is 1, 2, 3. This is 1, 2, 3, 4. So 2, 4 means we will fix this point. Let me consider this as A. And that can be represented by the point 2, 4. Then B, minus 2, 3. Where is minus 2? This is minus 1, this is minus 2, 3. So minus 2, 3 means here. So this is B. So the B is represented by the point minus 2, 3. Similarly, we can indicate the point C on C, that is a 0, 1. 0, 1 means x is 0 and this is 1, means this point. So this is C, that is 0, 1. Okay. And D is indicated as 2, 0. So 2, y is 0. So this point. So 2, 0. And we have similarly E at minus 5, minus 2 and F 1, minus 2, etc. So likewise we can have different points. We know already a complex number can be represented by a plus b, ib or x plus iy. So let me have some complex number like 2 plus 4i minus 2 plus 3i 0 plus 1i. They may correspond to the ordered pair, that is 2, 4. Similarly, minus 2, 3 and 0, 1, etc. So those figures are points are represented here. That is, when I say, and this is the point 2 comma 4 means this one, point A. Okay, minus 2 plus 3i, which is nothing but minus 2 comma 3, that is point B. Similarly, we have got 0 plus 1i, which is represented as 0 comma 1, as in this case as C. Likewise, etc. So the plane having a complex number assigned to each point like A, B, C, assigned to each point as indicated here as A, B. Each of its point is called the complex plane. It's also called Argand plane. So in an Argand plane, the modulus of complex number, that is represented as x plus iy modulus, is given as the square root of x squared plus y squared, which is nothing but the distance between the point P and O. Let us consider this example. Look at this graph, x-axis, y-axis. So I got a point P which has the point x, y. So the distance between this O origin and the point P is the distance OP. So the point P is represented as x comma y, and the point O is represented as origin, that is 0 comma 0. Therefore, the x-axis represents a plus I 0 and the y-axis is represented as 0 plus IB. So this is the Argand plane, in which you have the imaginary axis. So these are called imaginary axis now. It means this is the real part This is the imaginary part. So it can be called imaginary real axis. This is called real axis. And this is known as imaginary axis because it is associated with the y-axis. And both of them together can be called the imaginary axis. And this point OP, which is nothing but the modulus of x plus iy complex number. So according to this is nothing but the square root of x squared plus y squared, which is nothing but OP, the distance formula. Okay. Put it in the geometrical form as like this. And we have the mirror image of the point P on the, for example, first quadrant, second quadrant, third quadrant, fourth quadrant. In the fourth quadrant, you can have the mirror image, and which is nothing but